Welcome to the lecture on the observable properties of acids and bases. We interact with so many chemicals during our lifetime that it's hard to understand what is an acid and what is a base, what makes it an acid and what makes it a base. So right now we're just going to take a look at some of our everyday chemicals and start to identify what are those characteristics that put it into that category of acid or of base, and why do we call them an acid or a base. And so we're going to go ahead and get started, and we're just going to talk about the observable properties of these chemicals. So here's a couple of acids. We have a lemon, and in lemons, oranges, all the citrus fruits, we have something called citric acid. And this right up here is the ball and stick model, the kind of a three-dimensional rendering of that acid. And here you can actually see the chemical composition of citric acid. So the thing that makes citric acid acidic is the fact that it will donate a hydrogen ion in solution, and it has quite a few different hydrogen ions available because it has three what we call carboxylic acid groups. And so this hydrogen can be donated in solution. This hydrogen can be donated in a solution, and this hydrogen can be donated in solution, depending on kind of the properties of the solution that it's in. And so because it can donate a hydrogen ion, it's able to be considered an acid. Over here we have a very simple acid, formic acid, and if you've ever been bitten by an ant, one of those stinging ants, you felt the power of this little hydrogen ion right here as it goes into your skin and bloodstream. It will sting you with this formic acid. Aspirin is actually an acid. It is acetylsalicylic acid, very closely related to salicylic acid, which is another acid you might use at home as part of your face wash. And the way the face wash works is it actually kills the bacteria in your skin to keep it from getting any kind of bacterial issues. And so here, though, is aspirin. And we do have a acidic hydrogen here on this carboxylic acid. Are you starting to see that carboxylic acids are a carbon with two oxygens and a hydrogen on one of those oxygens, hopefully? And so this is one of the reasons why you might take buffered aspirin, because sometimes its acidity can actually upset your stomach if you take it too often or on an empty stomach. Here we have glycine, and glycine actually can act kind of amphoteric. And so amphoteric means that it can be an acid or it can be a base. And so we have this carboxylic acid. Once again, we have our carbon and our two oxygens, and here's that little acidic hydrogen, and then here's our amino group, and so that nitrogen can take on a hydrogen, and when it takes on a hydrogen, it's actually kind of stealing it from the solution and leaving the solution less acidic. And so between the two of these, it can behave in different ways depending on the solution that it's in. Caffeine, even though coffee is known to be acidic, the molecule for caffeine itself is a weak base. And so here we can see that there are nitrogens which tend to take on hydrogens, and we also have these oxygens that are double bonded, which means that they have a lot of electronegativity, and we can get a little hydrogen to bond here, and if you bond on a hydrogen, that removes it from the solution. Less hydrogens in the solution makes it less acidic because those free hydrogens are what give it the acid. If you've ever gone tide pooling, maybe you saw a sea slug, or maybe at least you saw one at SeaWorld or out at some kind of marine park, and sea slugs actually are able to excrete an acid in order to have self-defense. And so sulfuric acid, a very strong acid, this is what we call a diprotic acid. Now let's think about, what does protic mean? It means proton. And let's think about, what is a hydrogen ion really made of? It's made of, a hydrogen. A hydrogen is one proton and one electron. So if we remove the electron, making it positive, now all we're left with is a proton. So anytime I say proton, that also can be used in exchange for the term hydrogen ion. And so we call this diprotic, meaning that it has two hydrogens available to donate to the solution. This is one of the reasons why sulfuric acid is very strong, because it has a lot of hydrogens. It's able to donate. It also lets go of them very easily, dissociating strongly and making a very highly acidic solution. So the main thing that we think of when we think of an acid is hydrogen ions, H+. And so just like I was just talking about, H+ is also known as a proton. All right, and so when that proton is in solution, when that hydrogen ion is in solution, it tastes sour. It corrodes metals. That means that it reacts with the metals so that there's less metal remaining in the solid form. Acids are electrolytes, and an electrolyte is something that is able to transmit electricity in the solution. You might not realize this, but pure water does not transmit electricity, okay? So if you were in pure water and a hairdryer fell into the bathtub, there's no way to get electrocuted. Now, the problem is if you're in the water, it has ions because you're covered with ions. But actual pure water does not conduct electricity. However, once you add something that dissociates, that electricity can pass through those ions. And so when we talk about protons or acids, these positive and negative charges that are dissociated into the water are able to pass the electricity through, and so we call them electrolytes. Okay, think about that word. What do we usually think of? I think of Gatorade or Propel. All of those drinks that you drink for sports are full of electrolytes, and that's also helpful because your own conductivity requires electrolytes. In order for your nerve system to work, you actually have to conduct electrical signals through your neurons, and so those electrolytes help kind of your body send signals from one place to another. Now, acids are able to react with bases, and if you put an acid and a base together, you're going to get a reaction. Think about vinegar and baking soda. You've done it a million times. You probably saw someone make a fake volcano out of it at some point in your life, and so that's when acid, which is vinegar, reacts with a base, such as baking soda, and at the end, if you put equal amounts of that acid and that base, you're going to get salt and water, and you should get a pH right in the middle at about 7. Okay, so pH, hopefully you know this from before, but the pH of an acid is less than 7, depending on the number of hydrogen ions in solution. More hydrogen ions, it's going to be a lower pH. Turns litmus paper from blue to red acid, and sometimes when we talk about H+, we actually talk about the hydronium ion, because when H+ is in water, we get H3O+. So kind of we can use these two things interchangeably when we talk about that hydrogen ion. All right, so let's talk about common properties of bases, right? The most common thing we think of when we think of a base is soap, okay? Soaps, things that we wash stuff with, those are mainly bases. And maybe you never said a bad word in front of your mom, but if you did and you got your mouth washed out with soap, you probably tasted a very bitter and chalky taste because bases tend to be bitter. The thing that makes a base is that they produce hydroxide ions in water, thus reducing the number of hydrogen ions in the water. And these again are electrolytes. Bases are able to dissociate in the water so that you get all those charged particles and electricity can pass right through. Bases actually feel soapy or slippery, so if you're working with NaOH in the lab and your fingers kind of feel slick, you need to wash them off because that means you probably got a little NaOH on your skin. Bases can react with acids. They form salt in water just like acids react with base, and so when reacted on a one-to-one basis, we end up with a neutral solution because pH of bases are greater than 7. When we work with pH paper called litmus paper, it will actually churn it blue. Litmus is a test that we can figure out if there's an acid or base present because it has an indicator in the paper. All right, so it's been a few months since we went over naming of chemicals, and so we want to make sure that you're familiar with the way to name them or nomenclature. Okay, so let's think about acids with no oxygen, first of all. And when we don't have oxygen, we start with the word hydro. Okay, so let's say we have HF. There's no oxygen in HF. That means that we would call it hydrofluoric acid. Okay, because fluor will provide the stem that you plug in. Otherwise, you just follow these steps. So once again, if we have HCl, we have hydrochloric acid. Now, when we're talking about a oxy acid, so that's an acid with oxygen, we're talking about hydrogen ionically bonded with a polyatomic ion. Oh man, we are really going back to last semester. Polyatomics, that's those ions that have more than one atom in it. So like SO4 minus 2 is sulfate, or SO3 minus 2 is sulfite. Now, here's our 8 and our ite. That means if we have sulfate, it becomes sulfuric acid. But if we have sulfite, it becomes sulfurous acid. Okay, so I like to think that I ate it and said, ick, acid. Or if you remember, my other little mnemonic device is that it is a righteous acid. Okay, so if it starts with ite, it's a righteous acid. Ite turns to us, acid. If it started with 8, I ate it and said, ick, acid. And so those are some ways to remember how to name these. Or as this PowerPoint says, in the cafeteria, you ate something icky. So go ahead and try. We want you to try to name these on your own. So HBr, give it a try. Is there oxygen? No oxygen. So we must start with hydroblankic acid, right? So hydrobromic acid. All right, how about the next one? CO3. Is that carbonate or carbonite? That's carbonate. So you see that H2CO3 is carbonic acid. And that's what's in your soda, actually, because it is carbonated. And so it makes carbonic acid when it reacts with water. And that's one of the things that makes your soda carbonated and acidic. All right, how about H2SO3? SO3 is sulfite. That's right, sulfurous acid. All right, there's quite a few there for you to name on the paper, so take a minute, pause this, and try them on your own. All right, welcome back. Let's talk about what each of these acids is called. HI would be hydroiodic acid. HCl, hydrochloric acid. Since SO4 is sulfate, this is sulfuric acid. I ate it and said ick. Here, NO3 is nitrate, so I end up with nitric acid. Here we have chlorate, so we get chloric acid. And here, once again, we have an acid with no oxygen, and so we're going to have hydrosulfuric acid. All right, before we move on, I just want you to look at these. What do these all have in common? Take a look. What thing does every single acid have? Here, as well as here. That's right, they all have hydrogen ions. Every acid has a hydrogen, and that is what defines an acid, is the fact that it has a hydrogen ion that it's able to donate to the solution. Okay, real quick, we're going to talk just about some common bases. You can list these out on your paper. We have NaOH, which is sodium hydroxide. That is lye, which is a base that it can be used for all kinds of things, especially soap making, actually. And if you're a gardener and you have very acidic soil, you might add a bit of lye to your garden. Potassium hydroxide is in liquid soap. Barium hydroxide is used in making plastics. Milk of magnesia has magnesium hydroxide. Milk of magnesia is for your stomach. I believe it can be used if you have constipation issues. And here, aluminum hydroxide is an antacid. Now take a look at these. What do these all have in common? You might notice that the H is at the very end of all these. They do all have an H, but they actually have two things that are in common, and that's the O and the H. And if you remember, OH minus is a hydroxide ion. A hydroxide ion is what we consider a basic solution. Now there's other things that can be basic, but if you see hydroxide in this format, you know that you have a base. You know that if they went into solution, they would react with a hydrogen ion, making water, and so together OH is a base, and especially OH minus is a hydroxide. All right, so that's it for the first lecture, Observable Properties of Acids and Bases. Thanks for listening.